Hello, welcome to Chapter 11, Lesson 8. Today we're going to be talking about displaying measurement data in a line plot. You can represent measurement data for fractions of a unit in a line plot. The line plot's number line is going to look like a ruler. So here's an example of a line plot. It is just where we have values along the bottom. And then however many times those values show up, we put an X to mark its spot on top. Example 1. The science room has a collection of bugs. Each bug's length is measured to the nearest eighth of an inch. Make a line plot to represent the data. The measurement data are shown in the tally chart. Here's our tally chart. First, make a number line to represent the value. So first we need to do this, except for, I suppose, why not? Well, then next it says place next of each measurement data. So here, are there any 1/8 inches? No. What about 2/8 inches? There's 2. So then I'd put X, X. 3/8, 1. Put 1 X above 3/8. 4/8 or 1/2 is 2. 1, 2. Notice how I'm lining up my X's and making them all the same size as close as I can. 5/8 is 6. 4, 5, 6. 6/8 or 3/4 is 5. 1, 2, 3, 4, 5. 7/8 is 4. And 8/8 or 1 is 1. So that's what our line plot should look like. And now you kind of maybe it makes more sense as to like when I said however many votes, right? So this one had 6, this one had 5, this one had 4. So it really allows us to see our data and kind of easily see which one has the most and which one has the least, that sort of thing. Refer to example 1, find the difference in length between the longest and the shortest bug. So the longest bug was 8/8. The shortest bug was 2/8. Difference means what? Subtract, yep. So if I'm subtracting 8/8 minus 2/8, I just subtract my numerators. 8 minus 2 is 6. And then the 8s doesn't change, but I notice that 6/8, I can reduce it, simplify. So I can divide by 2, divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So the difference between the longest and shortest bug length is 3/4 of an inch. All right, for exercises 1 and 2, use the tally chart shown. Tally chart. All right, so the tally chart represents the widths of buttons collected by Bella's mother. Represent the data in a line plot. Okay, so if I look at 1/8 of an inch, we have 5 and 6. So I need 6 X's. Above 1/8 of an inch, please notice the title. I'm really glad that they're focusing on the title here. How many do we have on 3/8? Oh, do we have any 2/8? Nope. So next is 3/8. I have 3. 1, 2, 3. 4/8 or 1/2, I have 1. 5/8, I have 2. And 7/8, I have 4. Notice I skipped over 6/8. Okay, there's my line plot. Suppose the buttons that were 3/8 inch wide were laid in a row touching. How far would the row extend? Okay, so if you're not quite sure where to go with this one, you could always replace it with the 10 and 2. So let's say I had 10 2-inch buttons. How far would they reach if I laid them side by side? We would multiply 10 and 2. So the same goes for this. How many 3/8 do I have? 3. And I need to multiply that by 3/8. So remember when we're multiplying a whole number by a fraction, we put the whole number over 1. We multiply numerators. 3 times 3 is 9. Multiply denominators. 1 times 8 is 8. 9 over 8 is an improper fraction. So what I need to do is I can either do top divided by the bottom, right? Or I could do where I break it apart. So I can see that 8/8 plus 1/8 would be 9/8, right? 8/8, I can trade it out for a 1. So my answer would be 1 1/8 inches. There we go. Okay, here we have a little homework helper here. At the farmer's market, Jeannie sells beans. Her scale weighs them in fractions of pounds. Jeannie made a tally chart showing how much each handful of beans weighed. How much did the beans weigh all together? Okay, so they did the work for us here. So first they multiplied 7 times 1/4, 6 times 1/2, 4 times 3/4, and 2 times 1. Okay, so when they multiplied it all together the beans weighed 9 3/4 pounds. Here's our line plot. So for the question then down here it says, refer to the homework helper. What is the difference? Subtraction. Difference is the answer to a subtraction problem. So whenever we see difference, we know subtract. Between the greatest green bean weight and the least green bean weight. So the greatest green bean weight was 1 pound. 1 pound? Whew. And the smallest green bean weight was 1/4. Okay, so I have to subtract 1 pound minus 1/4 of a pound. So what I'm going to do is I'm going to change 1 into 4/4. Same thing, right? When numerator and denominator are equal to each other, means 1. So now I can do what 4/4 minus 1/4 equals 3/4. So what is the difference? 3/4 of a pound. Now we know 16 ounces are in a pound, so 3/4 of that would be 12. How did I figure that out? Because 1/4 of 16 is 4, so 3/4, I just multiply by 3, and I get 12. 12 ounces. All right, let's go to the next one. For exercises 2 and 3, use a tally chart. Okay. It represents the distance some children were able to ride on a unicycle. I have heard that some people during this distance learning are learning to ride a unicycle. Bought one off of Amazon or something like that. Not me, but some other people I've been listening to. Anyways, let's represent our data in a line plot. First thing, draw your number line. Goes from 1/5 to 1. Okay, so I'm going to start with 0. Call this 1/5. Make sure they're equidistant apart. 2/5, 3/5, 4/5, 5/5 or 1, right? 5/5 and 1 are the same thing. Okay, so how many 1/5? I have 6. How many 2/5? I have 4. How many 3/5? 2. How many 4/5? 2. How many 1s? 1. There's my line plot. Oh, no, it's not my line plot yet because I don't have a title. Title is distance. Distance in miles. We should always put the unit whenever we're doing something like, if it was time, we'd put in seconds, or time in hours. Weight in pounds, right? Money, we'd put dollars because it could be a different form of money that we were using, like euros or something. What is the difference between the greatest distance, 1, and the least distance written, 1/5. So we need to do 1 minus 1/5, which I know that 1 I can rewrite as 5/5. And I just, like last time I did 4/4 because the denominator I was trying to subtract from it was a 4. Here my denominator is a 5, so I'm going to turn it into 5/5 minus 1/5. Now I have common denominators already, and I can just subtract to get 4/5. So the difference is 4/5 miles. Or really, I like to say 4/5 of a mile. Draw conclusion. Walter practices piano for either 1/4 hour, 1/2 hour, or 3/4 hour each day. If a line plot shows 2 x's above each value of time, what is the total amount of time Walter has spent practicing? Okay, so I just need to do 2 times 1/4, 2 times 3/4, oops, 1/2 I should have fit in there, 2 times 1/2. Okay, so I need to multiply each of those by 2, and then I'll add them together. So 2 times, this would be 2/4, or 1/2. This would be 2 times 3 is 6/4. I could simplify it. It's improper fraction, but I'm going to keep it that way until after I'm done adding. Divide by 2, and get 3/2. Okay, and this is going to equal 2/2, or 1. So here, let's add these two together. 1/2 plus 3/2. So when I add that together, I get 4/2. So let's reduce it. Divide by 2, and I would get a numerator of 2 and a denominator of 1, or 2. Okay, so when I add these two together, I get 2, and then I have to add a 1 to it to get 3. So the total amount of time is 3 hours spent. Describe one way to use a line plot. To show, you can use a line plot to show the heights of the kids in my class. Right? Wouldn't that be kind of cool, as if we made a line plot and put everybody's height and kind of show what the spread was? That'd be neat. Look at the tally chart of the line plot from exercise 2 above. What was the total distance ridden by all of the children? All right, so I had to figure out a way to get this back up to the front. So here it is. So how to figure this out is I would take 6 times 1/5, 4 times 2/5, 2 times 3/5, 2 times 4/5, 2 times 4/5, and then I have to add in 1 at the end. So let's do 2 times 4/5. 2 times 4 is 8/5. 6 times 1/5 is 6/5. 4 times 2 is 8/5. 2 times 3 is 6/5. So if I'm going to add these together, I have 2 8s and 2 6s. And the 1, don't forget the 1. So 2 8s make 16. 2 6s make 12. So if I add these together, 6 and 2 is 8. 2 and 2 is 1 and 1 is 2. So that means that I have 28/5 plus 1. And I'm going to make 1 into 5/5. Oh, I could just add it on at the end. Maybe I'll do that. Scratch that. 28/5. So to figure that, what that would be in a mixed number, I'm going to do top divided by the bottom. Okay, 28 divided by 5 is 5 minus 25. I have 3 left over. Remember, this is my numerator. 3 This is my denominator. 5. 5 and 3/5. And then I need to add in my 1. See, this is why it's so tricky, because sometimes you might forget to add in that 1. So if I add 1 to this, I get 6 and 3/5, which is right here. Look at, they were hoping you'd forget to add in the 1, so they gave you that option. All right, that is all I have for you today. Thanks for watching.